engineers learn how to use science to make exciting things in the world, like roller coasters and jets. So today, you are the engineer, and you're going to use your imagination to make an airplane.
And we'll be showing you how science can make it better. But before we make our model plane, let's look at a few things that we know that fly. I'll start. Birds fly.
Airplanes fly.
Most times. Insects fly.
Bats fly.
Turtles fly. I guess we should explain that one.
Now, most of us think of flying as moving through the air, but for scientists, flying is moving through any fluid. For this bird, that fluid is air. But for a turtle, that fluid is water.
This is important to keep in mind, because later we'll show how this movement of fluid around our flyers is what actually allows them to stay in the air. So where were we? Oh yeah, turtles fly.
Jets fly.
Space shuttles fly.
Flying squirrel. Flying squirrels are awesome.
It's true, a flying squirrel is awesome. Plus, it uses a lot of the same science to fly that our model airplane will.
Model airplanes? Oh, right, model airplanes. So we want our flyers to fly well. So let's look at all the other things that we know fly well and see what they have in common.
They have wings.
They have a body, or what we call on planes a fuselage.
And they have a tail.
Another thing that they all have in common is that they are trying to stay suspended in the air, or water in the turtle's case. The space shuttle, glider, soaring bird, and squirrel all have three forces acting on it while it is in flight: lift, gravity, and drag.
If we look at the three forces acting on an airplane, we see that two of the three forces greatly affect whether or not our plane stays up in the air. The force pulling it down is gravity. When you're up in the air, gravity is constantly working to bring you to the ground. So what force keeps you up in the air? That would be the force of lift.
As you can see here, Jess pushes up on the plane's wings, even though gravity is trying to pull the plane down. Right now, the amount of force she is using to keep the plane level is equal to gravity, and there is no movement. This is Newton's first law in action, which states that an object will change its motion only if a net force is acting on it. As soon as one force becomes greater, say Jess pushes harder, the forces no longer cancel each other out and the net force is up, so the plane begins to go higher. If she pushes up less, the net force is down and the plane starts to go lower.
The same thing happens when a plane is in the air. When our glider is in flight, gravity is the force that is constantly pulling it down, and the force called lift is what keeps the plane in the air. If we can get enough lift on our plane, it cancels out gravity and the plane stays flying. If we have more lift, the plane goes up. If we have less lift, the plane goes down.
So the question now is, where does this lift come from? While in flight, the lift is generated by the plane's wings. None of our flyers would be able to fly without their wings. The amount of lift that is generated is largely affected by the type of wings. So let's take a closer look at some of our favorite flyers and see what their wings look like and how they work.
This eagle has wings that are long and wide. This glider's wings are long but narrow. Our friend the flying squirrel, his wings are short but wide. The term we use to describe the length of the wing from the body is the wingspan. To describe how wide it is, we use the term chord.
The important thing to keep in mind is that the span and the chord of each of these flyers are very, very different, but they all manage to fly.
So today, we're going to take things you find around the house and make our own model plane using the three basic parts that we mentioned earlier that make a good flyer: the body, the wings, and the tail.
Things you'll need for this experiment include poster board, tape, scissors, and several paper clips. Let's start by building the body of the plane. Take a piece of poster board and cut out a rectangle that is basically this shape. You may want to use a ruler to draw the lines out first to make sure they are straight. Next, you'll fold the rectangle in half lengthwise and then fold the two edges to the center. You should have your rectangle folded into 4 sections at this point. Now take the 2 outside sections and fold them on top of one another to form a triangular tube. Tape the ends and sides so the body stays together. You'll do this twice, so you have 2 bodies to build 2 planes. Now comes the fun part. You can take the body and make basically any kind of wing or tail that you want for it. You can make it have a big wingspan, but a short cord, or you can give your wing a short wingspan and a big cord. Just remember the things that we've seen fly and what they look like. Another thing to remember is that you'll want the wings to be even on both sides. So what you'll want to do is fold the poster board in half and draw half the wing starting at the fold. This will give you a full wing that is the same on both sides. For the tail, you can do anything. Just make sure it goes down the middle. This will help your plane fly straight. Once you've cut out your wings, just make sure that you tape it on in the middle. Now take your paper clips and add 1 or 2 to the front to give the front of the plane a little bit of weight. Now listen, this is important. When you build your flyer and you take it out for the first time, remember it's perfectly fine if it doesn't fly very well.
Right, because as engineers today, you'll observe what happened, try to understand why it happened, and together, using science, we'll find a way to improve what happened.
Now remember, write down everything that you observe when you take it out to fly, because when we come back, we'll show you how you can make your flyer fly even better.
The most important thing is just to have fun with it.
And we'll see you back soon.